thank you everyone for participating today. Thank you. We have some amazing stellar speakers today. Let me introduce you here quickly. This is the second episode for Space4Kids with my dear friend Janet. We are having very young STEAM innovators today, shaping the future of space. We have about 12 stellar speakers today, which my friend and moderator, Janet Ivey, she's the CEO founder of Janet's Planet. Through her Astro Academy and her friend Steve Sherman today co-hosting, we have the honor to have these children presenting to us. These are some future scientists, technologists, engineers. They will be presenting art and music. I will hand the mic straight to Janet to introduce you, perhaps to Steve, give him a brief introduction to our co-host and the speaker. So floor is all yours. I'm super excited and grateful. Thank you again for accepting our invitation.
Well, thank you always to this amazing platform that you have created. Before I introduce our first student speaker, allow me to introduce my wonderful collaborator this past 14 months at the Janet's Planet Astronaut Academy. He has taught alongside, but he is an esteemed educator. He is an IBM Global Educator. He has more education awards adorning his wall than one can even name. His name is Mr. Steve Sherman. He has a brilliant program called Living Maths down in Cape Town, South Africa, but his reach truly is around the globe. So Steve, would you like to say anything before I make my first introduction of our students?
I would like to just thank you very much for that kind introduction. I need to up your marketing fees. What I will say is that today we are going to be celebrating excellence, and I cannot wait to see what these students have put together. I've seen the range of topics, and I just know that the audience is going to be wowed by how smart, how well thought out these presentations are, and I'm looking forward to it. So I'd like to wish you all the best of luck.
And with that, I will tell you, audience, sit back and get ready. The world is in great hands. Our first speaker this morning is Catherine Manley, an 11-year-old student in 6th grade from Knoxville. She is the recipient of a 2019 scholarship to the U.S. Space Camp and was featured by Oak Ridge Institute of Science and Education in 2020, where she was interviewed for her aquaponics project. This year, she won the 2021 Robotics Student Engineering Design Challenge through ORISE with her idea of a machine that could condense clean water out of the air using thermoelectricity. Catherine is currently working on building a prototype to address the global clean water shortage. She's a frequent traveler, having been to 7 countries on 3 continents, is a lover of languages. She speaks Korean and is learning Latin and Spanish. Catherine is an avid reader of English literature and plays a variety of instruments, including piano and violin. Catherine, I will hand the mic to you, my dear.
Thank you, Janet. So today I am going to talk to you about my idea of a machine that can solve the clean water shortage. So before I get into that, I just want to say thank you all for inviting me here. This is a really great opportunity for me, so I'm really happy to be here. So if you look at the Earth, it's very blue. Most of Earth is water, right? But it turns out that approximately only 3% of all that water is fresh water. And even with that 3%, approximately 67% of people actually have access to clean water. So that means that 1 in 3 people don't have access to clean water, and that's a big problem in today's world because water is essential for all life. So this is my idea for solving this problem. It's called the Aquabot, and this is a drawing of it that I drew on Scratch. So the way this works is it has thermoelectric modules inside of it. Thermoelectric modules are these small modules that when you send electricity through them, they cause a temperature change. So in this drawing prototype, the electricity is taken from the solar panels, which initially take it from the sun. It can also be taken from the battery, which stores electricity throughout the day and makes it so that it can run at night when there's no sun up. And it's actually more efficient at night because at night the temperature drops closer to the dew point, so it takes less electricity to cool the interior of the Aquabot colder than the dew point, so the air can condense. So if the Aquabot was on, this is how it would work. The air would come in, and once it reached the interior, it would condense into liquid water, since the interior is colder than the dew point because of the thermoelectric modules. And that water is automatically clean because earlier in the water cycle, when it evaporated off of the ground, it didn't bring any contaminants with it. So when it condenses out of the air, it also doesn't bring any other particles along with it. And the Aquabot is small and portable, and it isn't as likely to break down versus the mechanical cooling system, which is what our refrigerators use, because there isn't as many parts. I designed it like this on purpose because my intention is to have it go to poorer countries that don't have access to clean water. And this way you don't have to pay as much because there aren't as many parts, and you don't have to worry about paying somebody to come and fix it. So this slide shows you how much water you can get depending on how much energy is available. So latent heat of condensation tells you how much water, depending on how much electricity there is. So we can get 1 mole of water from 40.8 kilojoules of energy, which is the same as 18 milliliters of water. So if the solar panel is a meter squared, we can get approximately 1.3 kilowatts of power per meter square from the sun. And then assuming that the solar panel has 30% efficiency, which is about the average efficiency rate for solar panels nowadays, we can get approximately 0.4 kilowatts of power per meter squared. And then keeping in mind that 1 kilowatt of power equals 1 kilojoule of energy per second, we can multiply that by 3,600 seconds per hour if we want to get the amount of energy available in an hour, and then we get 1,440 kilojoules of energy per hour. And then we can take what we got from part 1, 2, and 3, and we can do 1,440 kilojoules of energy per hour multiplied by 18 milliliters of water per 40.8 kilojoules of energy. And once we simplify that and solve it out, we get that the Aquabot can output 636.8 milliliters of water per hour, and then that equates to approximately 15 liters of water per day. Now this is a lot of water because 15 liters of water per day is about enough to supply for a large family, maybe 6-7 people. And if the Aquabot could be made on a larger scale, it could supply for an entire village. And if the Aquabot was transported to the people who need it across the world, it could push toward a healthier human population here on planet Earth. Thank you.
Bravo and well done. And I feel like if we had, I think this idea needs to be patented and immediately put into production. My friend, what do you have to say, Tien? It's like, do you have questions for her? This is just amazing.
I'd like to schedule some mentoring sessions with you, Catherine, to understand your formula. I shared with one of the team members, she's an assistant professor. She's astonished about the level of academic advancement of all of your presentations that she has viewed. So
this is profound. Catherine, let me just ask you this question. I see that your original award-winning project was about aquaponics. You seem fascinated with water. Why is that?
Well, I think that water shortage and just water is a big part of life. And so it's very important to us because we are living beings. So we need to make sure that we take care of the water and make sure that we have enough and that it gets distributed equally so we can all live together here on Earth.
Well, beautiful and well done. And I cannot wait to see this particular project in action. Everyone, this is Catherine 11 years old. Keep that in mind as you sort of digest what she just said. Thank you ever much. We're going to go now to Jacques Duga, who's going to tell us about where we're headed and the future of space exploration. Let me tell you a little bit about this amazing young man. And so his name is Jacques Duga. He's 12 years old. He lives in Cape Town, South Africa. He attends the Sweet Valley Primary School, and his main interests are space engineering and building Legos. In 2019, he moved from Chicago to Cape Town. His favorite activities are chess, surfing, playing the guitar, and skateboarding. And this is his first international presentation, and he's really excited to be participating. Jacques, I will now hand you the mic, my dear.
Thank you. Where are we headed? The future of space exploration. Right now, there is no secret that Mars is the next big destination for the world, and NASA and Elon Musk, SpaceX, all of those people are doing a lot of preparation. One of the main things that have happened in the recent years is Congress has passed a bill of $125 million for nuclear propulsion. There are two main types: nuclear electric, which would be ion propulsion, which you can go into depth after this presentation by yourself. It's very interesting. But it would use a nuclear reactor to run an ion propulsion, which would make the ship very efficient and be able to travel further. And then nuclear thermal, which is basically a reactor from Earth, the average nuclear reactor, except the output is used as, of course, kinetic energy and stuff. And then, but the problem with nuclear thermal is it needs liquid nitrogen for cooling. And right now there's no really good way to store liquid nitrogen for long periods of time because the molecule is so small that it can usually slip through bigger molecules, which would thus make it leak and many other problems appear. And then on Mars, we can't deliver food every few days, so growing food is something we have to do. The topsoil layer of Mars has toxic elements in it, which would kill plants. But if you dig under, it has stuff like oxygen and minerals in it. So on Mars, if we were to go right now, we'd have to dig under a few meters, feet, whatever you want to call them, and plant plants there. And then for meat, you'd have to grow it using stuff like they're doing in the labs, which isn't fully developed, of course, right now. And then there's Earth, where we are preparing. So in Hawaii, as some of you people know, there are people that go and live with a few other people for extensive periods of time to see how people would live. And every time they go out, they put a fake spacesuit on, etc. And then, of course, there's Spaceship, which is what Elon Musk and SpaceX are working on. It is a big vessel that can hold up to 100 people. But instead of landing like a normal SpaceX straight up and down, this one is so big. It's hard to imagine the size from the picture. But it has to enter the atmosphere straight, and then about 200 feet before landing, go straight up and down and then land, which is, of course, very different to your average SpaceX. And it's made out of a different material too. Is made out of stainless steel alloy, which is stronger and will last longer than most rockets because it can enter the atmosphere, go out the atmosphere more than once, so it won't how do I say this, burn up, corrode, and get damaged. Enter the Dragon. As you all know, in the recent years and past months, Elon Musk and NASA have launched Dragon Crew, which can hold up to 7 people, which is a lot more than the capsule, like the ones that were used on Apollo and the other ones. It has a good payload of 2,910 kilograms, which is used mostly for stuff like science equipment and future uses right now. It will help bring lots of things like people and equipment to the ISS, which will be used to conduct experiments in preparation for Mars and other space travel. But of course, who needs rockets when you have planes? In the past few years, a lot of companies have started making planes like that can carry another plane that can either enter the outer atmosphere and around that area, and some even planning to go to the moon in the next few years, which would be a major advancement, because this would make people like us able eventually in like 20 years to be able to go to space without needing a big rocket, which would be, in my opinion, very amazing. And then, well, what's next after that? Right now, who knows? We could go for Jupiter, Saturn, and even to the Milky Way. Also, the end of my presentation.
Bravo.
Thank you for watching, and I hope you enjoyed.
Bravo and well done. We do have a fellow kind of student here who really loves rockets. Nathan, do you have any questions for who, but knows, but you and Jacques could go into your own business someday. He could be your partner down in South Africa. Nathan, do you have any questions for your friend?
How does a fully funded NASA benefit from partnering with private space companies?
It helps because maybe NASA sometimes can't think of everything. Maybe Elon Musk, for example, has ideas that NASA may not have and may not have thought of yet. And it just is a good partnership, I think. It just eventually, yeah, because they can help each other. Also, Elon Musk was the first person to land a rocket straight up and down, and I think NASA really likes that technology and they want to have it.
Brian and Sean, do you guys have any questions for potentially your future business collaborator, space collaborator?
Do you think that maybe a multitude of companies could encourage more space exploration?
Yes, I do. Same thing as if let's say if a factory, it's supply and demand, if a factory produces too much of something, the price drops. So if a lot of companies made planes and rockets that could go to space, the production of rocket fuel and rockets would increase, which would in turn decrease the price of making them, which would of course make it easier for people to get access to space.
You know your stuff, my good man. Thank you so much for sharing. I see. Oh, Anahara, do you have a question? You have your hand raised. Do you have a question, love?
Well, I like rockets too. It's because how they can go into space without breaking apart, but some parts have to go back. And I know they land in some sea to have some nice landing.
Very true. And one of the things we can think about, Anahara, and another, friends of ours, they want to think about too how we can do that as recyclable as possible so that we don't harm precious spaceship Earth. So I think the way that you're thinking is like, it's fantastic that we reuse many of these materials, but is there a way we can reuse even more? All right, next up, and we have the amazing Lisa Daisy Bochers, who's going to, I cannot wait to hear about this. You're calling it the Orchestral Universe, the science behind sound in space. Let me tell you a little bit about Lisa. And she's loved music. She began playing violin at 5 years old. She says she's always loved music. She likes to play around on the piano with movie scores. And she's been fascinated by space for a really long time. She's even researched pulsars when she was just in 3rd grade. They've watched Jupiter and Saturn super conjunction in December, and she really loves watching supermoons. Oh, she can even treat us in the kitchen with breakfast wraps, fruit salad, and crunchy biscuits or iced tea. Lisa, right after this, we're coming over for breakfast. Please take it away. I hand the mic to you now.
Orchestral Universe. Recently, I've been asking myself, is it possible for sound to be in space and travel there? And can we see the universe with our ears? This is the Cat's Eye Nebula, and when I first saw it, I thought it was absolutely amazing. I really thought this was unreal when I saw it because, you know, it just doesn't really sound like this. This was taken by the Chandra X-ray Observatory. Real or fake? Now, sound has to travel through something for it to be heard, so I'll use solid as an example. So if I tap on my table, you can hear it from the other side of the table if you put your ear against it because it travels through the table. Now, it is claimed to be impossible for sound to be in space because, you know, that space is a vacuum. From 160 kilometers above Earth's surface, no sound can be transmitted. So ordinary people like me can only observe the universe or space by vision. Is that the only way, though? This was also taken with the Chandra X-ray Observatory. It is a star cluster near the center of our Milky Way. Sonification. How is this possible? Now, space scientists from NASA and other agencies use different types of electromagnetic waves from the Hubble telescope, X-rays from the Chandra Space Telescope, and infrared waves from the Spitzer Space Telescope. These agencies convert this data into sound waves. The following video I'm going to show you is the Helix Nebula. I thought it was astounding because it has so many strange sounds. Sound waves in space. Astrophysicist Dr. Gillian Bellery has discovered that sound traveling outside our atmosphere is actually possible. In the Perseus star cluster, there's gas filling it. Astronomers observed a supermassive black hole there, and they discovered that It has waves of gas traveling outward in a frequency. This frequency has been calculated to be the deepest note known to the universe. It's a B flat, 57 octaves below middle C. Conclusion. So what's really real? People who speak in music, like me, can experience the universe in a new and amazing way through sonification of electromagnetic waves. People who are blind or have visual problems can hear the sound of the stars and experience the starry skies. As we discover pockets of gas in space, we can learn whether there are sound waves carrying this information through space. Okay, this, you can probably recognize its funny structure. This is the pillars of creation. Well, hope you like the slideshow, guys.
Lisa, this is beautiful and wonderful. Are you familiar that with Stanford actually sampled and calls it the singing sun? And when you talk about that lowest note, that B flat 57 octaves below, there is this very deep hum. And I remember a fantastic band director of mine when they were trying to teach us relative pitch so that we could kind of tune our instruments better, had us go around and see if we could identify pitches from the sound, the pitch of our hair dryer to the pitch of the refrigerator running. So I think that would be a fantastic science experiment, is to take some of these recordings and begin to really draw those out and put them on staff paper. Are you up for that challenge? I think that would be fantastic. You could write an entire symphony. We're looking for, Explore Mars is looking for an artist in residence. Maybe you'll be that person someday.
Yeah,
Please
I
write
was
that
just hoping I could put together a whole lot of these recordings of space sounds and turn it into an actual song.
We serve at your good pleasure. We await that. When you do that, we will have a grand broadcast. To me, there's something so majestic, and just, again, realizing that sound plays such an important sense. I think that's why I'm super excited. I tell you another challenge I have for you. You can go to mars.nasa.gov and you can download the sounds that they have already taken from the microphones that are on Perseverance. So I'd add that to my my list of compositions to do. Brilliant, my friend. Thank you so much for sharing that this AM. Moving right along, we're going to head to my student, Sachita Upadhyay. I'm really super excited about this. I'm going to let her say, it's like, it is a Latin name for bacteria eating plastic, but for fear that I will not do the Latin justice, I am going to let her introduce her very own. I have known Sachita since last summer. She is an incredible student of mine. Her team has just won the Odyssey of the Mind competition. She's headed to Worlds. Just this year, I was able to sit in on her induction into the Junior National Honor Society. She is a future astronaut. She has many wonderful interests, but without further ado, Sachita, I will hand you the microphone.
Okay, thank you. Hello, today I will be speaking about a plastic-eating bacteria that can reduce the amount of plastic in the world. Plastic buildup is a big contributor to pollution. It can destroy animals to whole ecosystems, leaving many species without a home. Plastic material is everywhere. Plastic is made from crude oils and then is altered into the manufacturer's desired shape. After that, the plastic is used in packaging, which is thrown out soon after it is received. In 2018, only 8.5% of the total plastics in the United States were recycled, and in Australia, less than 12% was recycled. Non-recycled plastics often pollute the homes of many species. Plastic can take up to 1,000 years to decompose, and we don't have much time to find out a solution. The biggest issue with plastic is that it pollutes land and sea, which causes problems for all living beings, whether it is directly or indirectly. If it builds up, plastic can destroy whole ecosystems. Most of it is due to the lack of recycling. Since recycling isn't common, the next solution is to use a plastic-eating bacteria. Ideonella sakaiensis, found in Japan, seems to be the one that can help. It can significantly decrease plastic's effect on pollution and can also live on land and water, only when it is genetically modified by other bacteria. If controlled quantities of this bacteria is released into certain areas, we could solve this problem. The scientists are still researching this bacteria currently. It can break down plastic and be modified, which makes it implementable. The bacteria is also safe for ecosystems. This is a picture of the plastic-eating bacteria. This demonstrates how it secretes an enzyme so that it can eat the plastic to its basic monomers. Unfortunately, even though it's still being researched, it seems like the bacteria can only break down PET plastic. PET might not be the most commonly used plastic, but it is used in most carbonated soft drinks and water packaging. Next up, we have an image that shows that plastic is made up of carbon and hydrogen, and the stick and ball diagram is showing how the atoms are arranged and showing us the shape of the molecule. If these bacteria are placed into a river or a landfill and in a proper quantity, it could clean up plastic waste. This means that we could have a cleaner earth and less plastic. Also, if this works well in a small range, maybe its popularity in usage will increase over time and solve this problem once and for all. Thank you for listening.
Ideonella sakaiensis. Is that right?
Sakaiensis.
Sakaiensis. You know what? I'm going to try to practice that. Brian and Sean, do you guys have any questions for your fellow comrade here?
I think that this might be a fascinating bacteria for climate change. So.
And indeed, you expound on that maybe a little bit about how could it be implemented, Sachita? Or do you have ideas about that?
I was thinking that maybe we could ask like the government to start an initiative that could release small quantities into landfills or places in the sea where it is bombarded with plastic. And if there is a significant decrease in that area, it could start being implemented everywhere else.
Wonderful. Anyone else have a question on this topic or ideas? I see your hand, Mr. Sherman, Mr. S.
Hello, Sachita. I love the fact that you were presenting about these creatures that are eating up the plastic, but you did mention that they only eat a specific kind. Is there space to genetically modify these bacteria to perhaps broaden their dietary preferences? And then maybe we can get them eating a lot more than just plastic, but perhaps we could also put them in the ocean and they could also eat oil that is polluting the sea.
Yes, I think that's what the scientists are researching currently, so that it can be genetically modified. So if they figure out how to modify it so that it can eat not just PET plastic and oils, and it can eat oils and other types of plastic as well, I think that would be very good.
Sean, I see your hand, dear.
What inspired you to research this bacteria?
I've always been fascinated about plastic usage on our Earth. And there was a project that I had to do for an after-school activity. And it was all about plastic. And we started researching. Unfortunately, we didn't get to finish. But I finished the research, and I just thought it was very fascinating since I was from a young age.
Well, thank you so much. Oh, I see some other hands raised. Let's take another question. Lisa, I see your hand raised, and then we'll move to our next speaker. What's your question, my dear?
Have you heard about types of mushrooms that digest plastic, or is there such a thing?
I have not heard about that, but I could research. I'm not sure exactly what that is.
I think you guys are onto something. Wow, I see a whole consortium of scientists here, don't you guys? All right, moving along, I'm sure we could spend hours on any one of your topics. Next up, we have Abiboo's Nuwa City, the first sustainable city on Mars by Bailey West. Let me tell you a little bit about our friend Bailey. She's 11 years old. She's in grade 6. She's in Cape Town. Her interests include doodling, reading, being creative, and surfing, and of course, science. Science excites her, and she wants to study STEM and architecture one day. Bailey, I hand you the mic. Well, go ahead and tell us a little bit about why you wanted to think about a city on Mars as it loads.
Because I really like architecture.
And could you see yourself designing a city on Mars?
We can see your screen. We can see your screen now.
Perfect.
Maybe I actually could. So Nuwa was actually created by a global design and innovation studio called Abiboo. And Nuwa is a self-sustainable settlement on Mars, and it's being created on the slopes of a cliff, making it a vertical city inside the rock. And this protects it from radiation and meteorites. And there's only space for 250,000 people. So Nuwa is one of 5 cities that Abiboo have created on Mars. I only know of 2 other cities that are located in the North Pole and in one of the most extensive canyons. So the Nuwa residents will live and work in things called macro buildings. And these are excavations in the rocks that have been created by a 3D tunnel system. At the end of the tunnels on the cliffside, green domes allow for residents to enjoy parks and tend to experimental Martian crops. Skyscraper-like elevators connect the top and the bottom of the cliff with steps along the way in sky bubbles that lead to the macro buildings. The top and the bottom has trains and buses that move in a longitudinal direction of the cliff, and there are also paved roads that connect all 5 of the cities. At the very top of the cliff is called the Mesa. It's a wide open plain where all the energy is generated and food is produced and the manufacturing is done. And food crops will be 50% of our diet, while the microalgae will also be part of our diet, as it will be most efficient for space and resources and will help with water management. The bottom of the cliff allows for residents to socialize in big pavilions with awesome views of Mars. The pavilions are protected from radiation by large canopies that will hold all the cliffside excavations. The valley is also where shops, schools, hospitals, gyms, and universities will be. It'll cost you $300,000 for a one-way ticket to Nuwa. This ticket will provide you with a small unit to live in, access to all facilities like schools and hospitals, as well as food and a work contract. And if you don't like living on Nuwa, you can't come back to Earth. Thank you.
Wow, we can't come back, so we better like it. Fantastic. Does anybody have any questions or a quick question for Bailey? This is an amazing, amazing development. And yeah, it's like, any questions out there? Let me see. Kevin, I see your hand raised. What's your question, Kevin?
My question is, like, where did you hear about this, and why did you want to learn about this? Because this is really cool.
I actually heard about this from my mom. So I don't know where she heard about it, but she showed me to the website, and I decided to do it because I really like architecture. And this is like designing a whole new world.
All right, you guys are so fascinated by it. I am going to look at time and move on to our next speaker. This is another student of mine, Maggie Bober, who's going to wow us with sort of her presentation about snakes in space. When I met Maggie back in 2019, she was telling me that she had a snake that she would really love to introduce me to. And I was like, sure, but I've come to know Toby virtually. She's an 11-year-old homeschooler from New Jersey in the US. Like I said, she's one of my students at the Janet's Planet Astro Academy. She loves nature, has a very, very special appreciation and love for reptiles, and in particular snakes. She cares for 3 corn snakes, a crested gecko, and a dog named Maxie. She also studies karate. She's working to attain her brown belt. She loves aviation, and she's even working on her private pilot's license. In her free time, Maggie likes to snowboard, draw, and go looking for reptiles and amphibians. So Maggie, I'd like to hand you the mic, my dear.
Thank you, Janet. So this is my Snakes in Space presentation, and why I think corn snakes in particular, would be great to go to space. So I think a really great trait for snakes to have before they go to space is being arboreal. And if you don't know what that means, it means they like to climb and live in the trees. So can you see my cursor?
Mm-hmm.
One trait that arboreal snakes have is a prehensile or semi-prehensile tail, and they like to grab onto things with their tail, like how the snake is holding onto the branch so it doesn't fall. They can also take impact damage really well, arboreal snakes, in case they do fall. So I think bumping around in microgravity, that could be fairly useful for the snake so it doesn't take any permanent damage from like hard hits on the walls. Another great trait for snakes to have before going to space is to be very hardy. And by that, I mean adaptable to a lot of different conditions like this boa constrictor and corn snakes. And that'd be very useful because snakes are gonna be probably fairly stressed in space. So another great trait is to be a great eater. So these 3 snakes, this garter snake, this corn snake, and boa constrictors are all known to be, they fall into a family called constrictors. And most constrictors are opportunistic eaters, meaning they like to wait around for their food. So they will, they'll eat whenever they get the chance, usually. So they won't be very picky because they don't know when they're going to get the next chance to eat. So yeah. I think corn snakes in particular would be great snakes to go to space, not just because they're the best snakes ever, but because they're semi-arboreal, so they have all of the like semi-prehensile tail and great impact damage, the great ability to withstand impact. but they're great eaters, and they're very docile, which I think would be another wonderful trait before going to space. They don't usually bite, and they are very hardy. So yeah. Now, this is very interesting. Snakes were put into zero gravity once, and the test results were shocking. The snakes lose their sense of proprioception, meaning they can't tell their body from the body of another snake. So they would curl up into tight balls, like how they usually would curl up against other snakes when they're stressed in big snake groups. They'd curl up into tight balls or attack themselves, thinking that they were a threat. And I have a video about that. Here, one second. Sorry. Here we go. So you can see this snake is curled up in a tight ball. This is a black rat snake. Yeah. It's a black rat snake. So you could see it was curling up in the tight ball. So I think the test results would be different if they went to space rather than the vomit comet like that snake was in. Because it could only be in space for a brief moment, and if they could be in space for longer, then they'd possibly have more time to adapt to the space conditions. And even if they didn't, I think that even if they didn't adapt, even through all that stress, if they were able to breed in space, maybe if more generations of snakes could breed in space, they'd adapt better in microgravity, and then we could bring the microgravity snakes to Earth and see how they react to gravity. Another thing that might help them adjust to space is probably a better setup. So if you could see in that the black rat snake, even if though it was in microgravity for not very long, it didn't have anything it could possibly hold on to. So if you have a prehensile tail, you're probably going to want to grab onto things with it if you're a snake. And I think it'd just be better if these snakes could have something to grab onto and some type of hiding spot. But yeah, that's my presentation. I hope you enjoyed. Is there any questions?
Thank you so much. Can you tell them a little bit? Oh, we've got several questions. All right, let me just go to you guys. Jacques, what is your question for Maggie?
I want to know if there are any plans for NASA or any other countries if they're going to send any snakes up. Do you know of any of these? If there are any?
There's nothing, no experiments I'm aware of right now about snakes going to space.
But tell them how you sort of came to this idea. Tell them about the geckos in space.
Yeah, so I did a presentation for Janet not that long ago about, I was looking for snakes in space, but I couldn't find any information. So there was a geckos in space presentation that I did. And actually, there's something cool about that was it was believed how geckos could stick to glass. It was believed gravity was needed for that. But it turns out that gravity wasn't needed for the geckos to stick to sides because they didn't spend any time floating in microgravity. They spent, I think, 99.9% of the time sticking to the walls. So that was a new thing. And then using that information, NASA actually came up with a new design for a Gecko Gripper, which they're going to use, which they said they might use for like little robots that could clean. And it's like a material that they came up with. And when you apply pressure to it, it sticks just like a gecko. And when you don't, it doesn't. And it doesn't need a matching side like Velcro. So that's pretty cool.
Anahara, what's your question, love?
Why are you talking about snakes in space?
Why are you talking about snakes in space?
Well, because I really love snakes. I kind of skipped the whole being scared of snakes phase and just went straight into the fascination part. So I've just kind of loved the way they moved and how they grabbed and got around without hands or feet. So yeah, that's kind of it.
Dylan, last question before we move on to our next speaker. What's your question, love?
Why would snakes be useful in space? What is the benefit?
I'm not actually sure. There could probably they're snakes. They're unique in a lot of ways, and I'm sure that could be used for some kind of information. I'm not sure what the benefit would be besides the knowledge of how snakes move. And I really like snakes, so it'd be probably pretty cool if I ever went up to the moon or Mars someday. I could probably still bring my snakes with me. So yeah, even if they had a hard time in the microgravity part. But I'm not sure what they'd actually be used for.
What would they eat?
So they would probably eat. So there's actually a species of snake called an egg-eating snake. That would probably be pretty cool. They don't have any teeth, so of course they're docile. But they would eat turnix and button quail eggs. And that might be a little easier to feed them because some snakes eat live mice rather than the frozen mice I give my snakes. And of course, no one really wants that to feed their snakes. Live mice, it's kind of sad, but also the mice could chew the scales off the snake, so they'd probably either eat frozen mice or the egg-eating snakes would eat eggs. They don't eat their own eggs though, so sorry about that.
Thank you so much for this presentation and all your research. All right, next up we've got Olivia Castleton, the challenges of interstellar space. And Olivia is also 11 years old from Cape Town, South Africa. She thoroughly enjoys learning. She's got a particular interest in math and science. She likes dance and drama, and she loves her cat. She's the oldest of 4, and she is here to tell us about the rigors of interstellar space. Olivia, I hand you the mic.
Hello, good afternoon, good evening, good morning, wherever you are. I am going to be talking about the challenges of interstellar space travel. Okay, so there are 4 major problems, and then there's a few possible solutions as well. The first problem is the time and distance. Our nearest neighboring star and exoplanet is called Proxima Centauri, and it is 4.2 light years away, which is the equivalent of traveling to Mars and back 70,000 times. Given that it takes 7 months to travel to Mars, it would take plus minus 80,000 years to get to Proxima Centauri at the same speed. The next problem is the required energy. Since it would take so long to get to our star, scientists recommend a minimum speed of 10% of the speed of light to get there. But still, the trip would take plus minus 40 years. The energy required to generate those speeds is enormous. And you also need extra energy to stop when you get there. You can't just go zooming past your destination at 10% of the speed of light and not stop when you get there. Going at these high speeds causes new problems, like space dust. At these very high speeds, space dust can cause huge damage due to the large kinetic energies involved. Scientists have some ideas to solve this, but lots of unknowns still remain. Then there's plenty of other tech issues, but there's also the impact on astronauts. Long-term weightlessness can cause your muscles to shut down, your skeleton to become weaker, and your heart to become weaker. Space radiation can also be dangerous. It can cause increased life risk for cancer, central nervous system effects, and degenerative diseases. The longest single stay in space is 340 days. 40 years is a long time. And then finally, we get to the possible solutions. This can be split into 2 branches: the slow crewed missions, which means it will take a long time to get there, and the fast crewed missions, which means you're going faster and you're going to take a shorter time to get there. For the slow crewed missions, you have 3 major possible solutions, all which seem like they came from movies and are science fiction. You get generation ships, which are, you send a small population of people, they will reproduce and then die, and then the babies will reproduce, etc., etc. Then you also get the suspended animation, which is basically an artificial hibernation that they can put people in. And then finally, probably the most crazy solution, frozen human embryos, which will have coded robots that will unfreeze these these egg cells when you get to the destination and look after them. It's a bit crazy. And then you get to the more uncrazy side, the fast crew missions, which means you will go faster and you'll take a shorter time to get there. There is time dilation, which means as you are slowly approaching the speed of light, you will start experiencing time differently than people on Earth would. So 40 years on Earth would be less for the crew. But since people can't handle this acceleration, there's also the constant acceleration methods, which means you accelerate half the way there and then start decelerating when you get there. Of course, all of these seem like, I don't know, crazy, because our science isn't advanced enough to do that yet. But just because something seems impossible, it doesn't mean it's not worth trying. Thank you.
Oh, brilliant. Brilliant, Olivia. Do I have any questions out there?
I was wondering, like, how, since we don't have that high technology yet, if hypothetically, how do you think the freezing of the embryos would work?
I never said I did think it would work.
Yeah, I've like crazy ideas like that. I was just wondering if you had any idea how that would possibly work, because it sounds great, but I would have no idea how it would work or anything like that.
It wouldn't work.
Yeah, no, I mean, we'd have to get a lot more technology first, but I was going for hypothetically, but that's awesome.
All right, Brian, I see your hand.
I like your presentation.
Cryogenics.
An amazing blend of quantum physics and medicine. And is this something that you'd want to go through on and research?
Thank you.
Would you like to go into maybe quantum physics and some like interstellar medicine? I mean, these are properties of might be possible.
They could be possible. I'm not sure. I didn't really research that.
All right. And Catherine, what is your question, love?
So this is a sort of a comment, but I was thinking that if you, with the constant acceleration thing, if you continue to accelerate at 1g continuously, couldn't you erase the problem of the whole muscle breakdown on the body because you're constantly accelerating at 1g? So to the body, it seems like you're just at 1g, but you're just accelerating at 1g. So wouldn't that erase the problems with the human body?
Yes, it gives you that advantage. If you're accelerating at 1g, then there's gravity.
And the other thing is that for the human body, we like constancy. So if in that possible constant acceleration, I believe that's the biggest key, especially if we're looking at a faster crewed mission. But again, if there is a way that we can, quantumly figure that out, that constancy and that acceleration that doesn't harm the human body, then I think that we'll have some real breakthroughs there. Brilliant, brilliant. Again, fascinating, everyone. Let us go to our next speaker. How going back to the moon is helping us to prepare for going to Mars. And this presentation is being done by Lucas Lowery. Again, I am delighted to say that I met him also in 2019 doing a camp in New Jersey. He's been part of the academy. He's 7 years old. He's a second grader, and you will be impressed. Lucas enjoys all things space, science, and math. He hopes to become a mission specialist engineer for NASA when he grows up, and his ultimate dream would be to be the engineer to build the first amusement park in space. And space is actually the perfect setting for Lucas, who's already always in constant motion. When not deep diving into space topics and participating in science and math classes, Lucas plays hockey, soccer, and he also skis. He loves roller coasters and history. And here is Lucas. Take it away, Lucas.
Hello. I'm going to show you the importance of going to the moon again before going to Mars. So, there are a lot of reasons why it's important to develop missions to the moon to help us prepare for manned flights to Mars. First, NASA needs trial runs of escaping the gravity of the lunar planet. Yet, the SLS needs trial runs before going to Mars, even if the moon has 16% of the gravity of the Earth. Mars has 38% of Earth's gravity. Practice helps scientists to navigate the rocket under different conditions. Since the SLS is new, we need practice escaping a planet or a moon. Last time we escaped the gravity of a moon or a planet was 49 years ago. Astronauts have only left the gravity of the Earth a half or a dozen or so times. As velocity changes depending on the size of the payload, different weights of cargo need to be tested in launching out Earth's gravity. Next, NASA needs to check their life support systems. Checking life support systems is one of the most important things about sending astronauts to Mars. It's also the biggest problem. These systems need to be updated if we want to go to Mars successfully. NASA has been working on landers with 3 different companies. The areas that need to be focused on to get humans into space include environmental monitoring, atmosphere management, water management. In addition, NASA needs trial runs on surface exploration. A lot more of the systems are automated and need to be programmed correctly. We need to run more than analog or simulated missions. Some potential difficulties of space exploration with surface exploration includes space dust in spacesuits. It's been a problem since the Apollo missions. Terrain issues. Data can impact landing and navigation. Pools on the surface need to be tested for their ability to function and to see possible problems. Testing surface exploration vehicles is important to see problems before going to Mars. Finally, NASA needs to build and test the Gateway before using it for the long distance to Mars. The Gateway is like the International Space Station, but will be further into deep space. The spaceship needs to dock to Gateway to refuel and prepare for the rest of the trip to Mars. The Gateway will be where the astronauts will change ships for final descent into the Mars atmosphere. Some of the technology that is needed for scientific feat can be tested in missions to the moon before launching a deeper space station into Mars. In conclusion, the lessons that NASA will learn by manned missions to the moon help a strong space program transport astronauts to Mars in a safe and efficient way. Thank you for your time.
Thank you, Lucas. Anyone have any questions for Lucas? You are pretty succinct in all your things. It's like we just need to let NASA know that you are very much touting some of the things they're going to need to really rehearse and practice and do before we can send humans back to the moon and onto Mars. Thank you so much, Lucas. We're going to go now to Mary Botha's presentation. She says we need to avoid school strikes on Mars. So we're very interested to hear what she has to tell us about this amazing topic. Let me read just a little bit about her. Pardon me. She is also a student of my friend, Mr. Steve Sherman's down in Cape Town, South Africa. She loves to sing. She's interested always in learning new things. And she's always like figuring out math problems and asking questions. Perfect scientist. Her grandpa has a collection of National Geographic magazines, and she has spent hours looking through them. And she claims this has really sparked her interest in space and history. So she is looking very forward to seeing where and how humans will travel further into space. Mary, I hand you the mic.
Hello, everyone. Thank you for this opportunity. Can you hear me?
We can, perfectly.
Thank you. My generation has grown up on a damaged Earth, a planet we haven't taken care of, and one we are still not. My generation has undertaken school strikes to draw attention to the damage we are causing, to pollution, to the extinction of species, to climate change. We need to listen and we need to learn. As we travel further into space, exploring and planning to settle on the Moon and Mars, we must do better. We've not started well, leaving space junk orbiting our Earth, and instead of just footprints, we've left more than 200 tons of waste on the Moon. Everything from moon buggies to golf balls and bags of used wet wipes. It's so important that we change this and that we build respect for our environment into the core of all our space travel plans. After all, it's the very things that we've taken proper care of on Earth, that we haven't taken proper care of on Earth. Clean water, air, that are so important to us surviving on Mars. Things that we have been careless about, our energy sources, our use of the environment, our waste, are the things that we need to care more about. How do we do this? A lot of thinking is already in place. It's the commitment to the action that we need. We need to commit to using sustainable sources of energy, to design our spacecraft and our settlements to reduce waste and remove pollution. We have to commit to closed loop systems where we keep material in use. And we must undertake to leave the least impact possible on any natural systems we find. If we must make use of the resources on the Moon and on Mars, we must do so with the utmost care, using only what we need. Solutions built on these principles will need to be efficient, smart, and sustainable. We will need our best thinking. The lives of our astronauts will depend on that. And if we can get this best thinking right, the ideas and technologies right for our trips to the Moon and to Mars, we need to bring them back to Earth too. The technology and also the inspiration to build a more sustainable way of life. A way of life that does not waste. A way of life that takes care of our environment. A way of life that the next generation, our children, won't have to strike against. Thank you.
Bravo and well done. I will go with you wherever you would like to travel, my dear. I love your passion for making sure that we can't really be good crewmates here out there if we're not good crewmates here, is what I hear you saying. Jesse, do you have a question? I see your hand raised. What's your question, love?
That was for a different slide. That was for I didn't mean to keep that up, sorry.
Brian or Sean or Nathan, any questions for our friend Olivia? Brilliant. We have another kind of climatologist here as well, kind of thinking about, we have a kind of a running theme here, is that how do we do all of this, take care of the best natural resource, the human, and also take care of those places we will be exploring. Yes, Brian, I see your hand.
So sustainability will be like part of the education from the get-go.
Oh, that's brilliant. So Olivia, what do you think about that? We just put sustainability and education in there right up always, right?
Yeah.
Well, like I said, I want to talk to each and every one of you for days on end, but we do have 3 more presentations. I'm going to turn now to our next speaker. He's going to share the art of space and why it's important. This is Jesse Burdett. I met him last year as he joined our Janet's Planet Astronaut Academy. He loves space, he loves science, but he is an incredible artist. He also does some really fantastic voices. He's interested in being an actor. His favorite play is Hamilton. Jesse, I hand you the mic.
The art of space and why it is important. Why do art and space go together? Well, that's what I'm here to teach you. Space art has been a marketing tool for centuries to help people get excited about NASA, and really overall to help people really understand space better, just with art. As the centuries unfold, millions of artists will live on the moon and paint the moon and Mars as we go out into the universe. That is former NASA astronaut Alan Bean. That was his nickname as his time as an astronaut. It really is hard to imagine that the space-crazed general public of the 60s needed any help getting worked up about astronauts, and NASA in general. It could have been the wild popularity of space-related imagery in part of what motivated the NASA administrator at the time, James Webb, to create the NASA art program in 1962. How many artists have worked with NASA? Over 350 of them, to be exact, including many famous artists such as Andy Warhol, Norman Rockwell, and Laurie Anderson. They've brought so much effort and time into many of these NASA projects, and it's just incredible. One of the participating artists in NASA's space program was the postage stamp designer Paul Cal. He produced a stamp commemorating the Gemini 4 space capsule in celebration of NASA's 9th anniversary. And there you can see the picture drawn by him. Many pieces of the NASA art collection from this time and many other times are on display at the Kennedy Space Center Visitor Complex in, of course, Florida. The two-story gallery at the complex exhibits paintings, photographs, and drawings showcasing the different ways artists express what they see. Many of them, including Andy Warhol's Moonwalk 1, as we saw in the previous slide, and the postage stamps that Paul Cal have created are all in that museum. Thank you. Thank you for listening to my slideshow, and you can actually look for my art. I have a weird signature, so you can pretty much figure out it's mine. And thank you to openculture.com for a lot of the info that I found in this slideshow. Thank you.
For now, we will move on to a dear friend and student. These are students from Florida. My dear friends Kevin Simmons and Shauna Christensen are their teachers, and Dylan Kiesling is here to tell us all about paving the way to universalization. And let me just give you a little bit of background on Dylan. Again, what we have here are so many amazing students, and I hope that those of you listening in. He's 11 years old. He's a 5th grader. He's a member of the Wolfpack CubeSat development team and Aerospace and Innovation Academy. And on this team, he enjoys learning about orbital mechanics, doing CAD modeling, and participating in space settlement competitions. And here he is to tell us about how we're going to pave the way for universalization. I'm going to get that word right here in a second. Dylan, take it away.
Hi, my name is Dylan Kiesling, and I'm 11 years old. I'm a 5th grade member of the Wolfpack CubeSat development team located in Palm Beach Gardens, Florida. On this team, we participate in a lot of aerospace activities, such as building high-altitude air balloons and small satellites called CubeSats. We also advocate on behalf of the aerospace industry and present our work at conferences. One of my favorite things to do is to work on space settlement ideas. Our team participates in space settlement competitions, and through this work, we learn about different aspects of how humans will live in space. Today, I will talk to you about a paper I'm currently working on, which I'm writing with my older teammates, which we will present at a global space exploration conference this summer. Our paper is about international cooperation and how it can help paving the way towards universalization. So what is universalization? Well, this is about how humans will live in space, how we will get there, when we will settle, and how these settlements will work. Many scientists are working on projects to build space settlements on the moon and on Mars, and even on orbits of different planets. But what will happen when people actually get there? Who will be in charge and how will society function? It is very important for all countries to figure this out because one country cannot own a planet or rule the universe. Nations will need to work together to develop a framework on how they will live in space and share that environment. The first thing that will need to be considered are logistics, such as the air we will breathe, the food supply, and electricity. Secondly, nations who live in space settlements will have to agree on factors related to society setup, such as housing, transportation, government structure, what currency to use, and what language to speak. In order for settlements to be sustainable and useful, it is also important to develop an economy. For example, will there be different jobs there? Are we going to mine for precious materials and break out water from ice? Also, what about important materials such as plastic or glass? Will we get those from Earth or make them on the space settlement? But first, nations need to work together to actually get to space and build the sustainable space settlement. Global cooperation and teamwork between nations is very important in space exploration for many reasons. To name a few, it can figure out the best solutions. We can combine technology and resources to make more sustainable space settlements. And most importantly, through collaboration, people can make sure that everybody gets along and every country is represented in the space environment. For example, after many years of Russia and the United States fighting and competing in the space to race, it was teamwork that brought them together to build the International Space Station, which promoted a completely whole new era in space exploration. In the same way, international collaboration will be necessary to reach new milestones in space exploration. When humans start settling in space, international cooperation will be necessary. Global partnerships will help more countries to develop sustainable space programs so that more countries can be represented in space. It will also help everybody achieve more goals both on Earth and in space. When countries work together, share knowledge, and educate each other, they can achieve greater things in space exploration and ultimately pave the way towards universalization. Thank you.
Thank you. This is such an important topic, and so that we have people like you thinking about things like the Artemis Accord based on the Outer Space Treaty. I see a question. Is it Fazia's iPhone? Would you like to ask a question? And I see Sean's hand. Fazia?
Yes. I wanted to know if there'll be countries or cities in space. So if we go to live in space, if there'll be cities or countries or towns.
Oh, well, we think so. Would you like to take and try to answer that, Dylan?
Oh, yeah. Well, yeah, we're going to be governing in space. We're going to have space settlements on orbiting or on the planets. And a space settlement is basically a city or a town. So yeah, I guess it could be considered one of those.
Absolutely. All right, Sean, I saw your hand. What's your question, love?
Dylan, I liked how you presented that space would be a democracy. Do you think this will be how to do?
Sorry, can you repeat that?
Yeah, what was that last part, Sean? He really appreciates it being a democracy, but I think we didn't catch that last part.
Dylan, I said I like how you said that space would be a democracy. Do you think it'll be how to do this?
Is it the best way to do this and forge universalization and democracy to have a representation of all?
Oh yeah, we do all have to get along because we need to share technology and knowledge to build, better space settlements.
Well, I am quite certain that I think a career in space law could be in your future, my good man. Brilliant. Let me introduce you to Owen Welch and Alexa Ernst. I had the pleasure of having Alexa on a panel at the Human and Mars Summit a couple of years back, and I think she is the future president of Explore Mars. So Alexa, no, you're on my list. They're going to talk to us about the mitigation of lunar dust using electrically charged spacecraft surfaces. And again, both of these great students are also part of Kevin Simmons and Shauna Christensen's class. Alexa is now a sophomore in high school at Florida Atlantic University High School. She's majoring in physics and data analytics. She's focused on science and math. Her favorite classes are physics and calculus. She's participated in numerous extracurricular activities. And in 2019, she won first place and best in fair for her science fair project in the state of Florida. She also is an active member of the CubeSat team, which developed the WISE-Sat-1 that was carried on the SpaceX Falcon that launched on December 4th, 2018. And she's currently working on a lunar rover project called Amaris. And so that is one of our presenters. And then Owen is her co-presenter today. I am sure that you guys are going to be fascinated by him. I also got a chance to hear him speak before. He's a junior at William T. Dwyer High School in Florida, where he enjoys playing basketball, participates on the debate team. In the past few years, he's been given the opportunity to speak at the Human and Mars Summit in 2018. He also has helped design and develop a CubeSat, and he's helped to lead a team of students to compete in the Future Space Scholars Meet Finals in Beijing. His goal in life is to become immersed in the world of physics and learn as much as he can from those above him so that he can one day become a physicist himself. Guys, I give you the microphone, but I'm quite assured that amongst all of you today are future Nobel Prize winners. Alexa and Owen, you have the floor.
As stated, our project is the mitigation of lunar dust using electrical charged spacecraft surfaces. So there's been many problems and difficulties regarding the lunar dust on different NASA missions. For example, the Apollo missions had difficulty functioning due to the dust. Now, this dust, one of the main issues with it is because it is directly exposed to the sun, because there is no atmosphere on the moon, it gets direct exposure to UV radiation, which electrically statically charges the dust, which means it has a positive charge. This causes it to stick to almost anything. It's almost like if you stick your hand into a box of packing peanuts and pull it out, your hand's gonna be completely covered in the packing peanuts. And it's the same effect as with the lunar dust. So the particles of the dust are extremely sharp, which causes it to cut the spacesuits, and it's also very abrasive, so it causes it to damage equipment like the solar panels. And this dust is made up of elements that are extremely toxic, which is very hazardous to the astronauts' health.
So our main goal is to try and mitigate this dust and find ways that we can repel it from our equipment and our spacesuits so that we don't have to deal with all of these adverse effects. So we based our experiment around Coulomb's law, which states that like charges repel, whereas opposite charges attract. So like Alexa said, since this dust is positively charged, we're trying to find ways to positively charge our equipments and our spacesuits so that way it can repel all the dust away from it, as Coulomb's law states. So we used a Van de Graaff generator, which you can see on this slide right here, which I'm sure many of you are familiar with, to try and ionize this lunar dust by shooting electrons at it and trying to knock off other electrons and create a positive charge on our lunar dust. We bought this simulant from a university, and it's as close as we're going to get to this lunar dust on Earth. So in order to test this with our experiment, we used ITO plates, which are simply two plates that when you add electric charges to, create almost a field between them of electricity. One is positively charged, one is negatively charged. And we were able to find that the ITO plates in some of our tests repelled from the positive side from our ionized lunar dust, which was an amazing discovery because we actually got to see the fruits of our labor once it repelled and showed that maybe this idea could be applied further in space and on the moon one day.
So for our future experimentations, we want to repeat our experiments and we want to also revise the equipment and the methods. So we want to refine our testing environments. One of our main challenges is that it's very difficult to simulate the lunar environment. So as we stated, the lunar dust is electrostatically charged, it's positively charged, and it's very hard to find an accurate simulant to that. So it's hard to find something dust that is also electrostatically charged the same way it is on the moon. And another difficulty we had is calculating the electric and magnetic field.
So our next steps, like Alexa said, is to complete more tests and to try and find new ways to simulate the environment that's closer to how it is actually on the moon. Because right now it's similar, but we want pure data from tests that are like on the moon. And then after we find new ways to go about testing this and simulating the environment, we're going to start constructing the prototype for our rover that we are hoping to launch as soon as possible. We've already found all the materials that we're going to use to create the rover, and we just have to buy them and construct them once our tests are done. From there, we need to find a way to apply our electric field system that we were talking about to the rover to try and find ways to repel the dust, because that would be the main goal of our mission. So overall, we just have to build, test, design, and then launch our rover as soon as we can. Thank you.
Again, always impressive, our students and friends from Weiss School, our very fantastic friends from Cape Town, South Africa, and my students know that I am always super proud of you. We have neared our time as well, but I just want to say thank you. Again, if you guys are out there listening, this is what I absolutely love to do, and I'm so grateful that that my friend is giving us the platform of her Space Connect to have us do these periodic Space4Kids podcasts, so that all of you good and great humans that are also interested in the very same things know that you have got a pipeline of talent that is coming and creating and will be there to carry on all of the things that we are dreaming. So, Mr. S, do you have any final words? And then I'll throw it back to our lovely host.
Absolutely. As someone that is involved with science expos, I often get to go as a judge to these events, and I've been to a couple in different African countries as well. And what I found fascinating is that there's a new trend taking place around the world at science expos, and that is businesses are now attending these events to come and collect ideas for the next big thing. And that is because they see these students, they might be young, but they are full of potential. They are coming up with fresh new ideas that the rest of the adult world are not seeing. They are identifying niche areas and new scientific discoveries using technologies that many of these adults don't even know about. And what I find remarkable is that anyone that is watching this set of presentations today will be blown away by the depth and the width and the heights that many of these presentations have gone. And I'm very excited to see where they are all going to be heading in the future. And hopefully they will remember some of these educators that were standing behind them and cheering them on and saying, you're doing a great job, but please remember us, because I'm sure they're all going to be very famous in the science world in the not too distant future.
Beautiful words there. Thank you so much, everyone. You're all stellar public speakers, and thank you for your remarks there, Steve. We are all inspired by the depth of that passion and the purpose you, as young STEM innovators and social innovations we have learned, and technologists and future serial entrepreneurs. So we hold the torch for you. The torch has been passed over to you. Whenever you need help, there is the platform of UNOSA Space for Women. You can visit that webpage and apply to become a mentee, and it's free. It's a free platform. So this initiative has been built up on that initiative in order really to support you young STEM girls and women and boys, and you know, so you're just one click away to get all of the support that you need. Thank you all, and stay well, and we hope to cross paths again in the future.